All right. On number one here, the review for chapter one final, there's two choices here. You can move the 7 over first and get 26 and distribute the 4. Or you can distribute the 4, combine the like terms of what's going to become these numbers right here, and then move that one number over. So it's really personal choice which you do first. So it's going to be 4x plus 20, distributing to both of these, minus 7 equals 19. Combine like terms here, we get 4x plus 13 equals 19. And subtract 13 from both sides. That's going to give me 4x equals 6. Divide by 4. And we really have our answer there, except we always want to reduce. So that's going to be 3 halves. You can also write it as 1.5 or 1.5. Doesn't matter, same answer. I'm not going to write it out, but if we would have moved it over, we would have had 26. And then we would have subtracted 20 and still gotten the 6. So it's still the same work. It just depends on what you want to do first. Some people might see this and say, oh, move the 7 over first, then distribute, then move the 20 over. It's really just personal preference. Neither one is better than the other. All right, number 2, we got a lot of distributing to do. So we're going to distribute the 3 here and here, the 2 here and here, and then combine like terms where we can. So on the left side, we end up with 3x plus 24. On the right side, we end up 2 times 3 is 6x. 2 times negative 1 is negative 2. And then this is minus x. Now be careful. Some people get too excited and distribute the 2 and keep going here. But that is not in parentheses, so don't do that. It's a very common mistake to put negative 2x. Don't do that, just negative x. Now on this side, I'm going to combine like terms. All right, so it's going to give me 3x plus 24 equals 6 minus 1 is 5x minus 2. Now, you can move the 5x over and get negative 2x, or you can move the 3x over and get positive 2x. It really doesn't matter. It's personal preference. I like to keep my x's positive. So I'm going to subtract the 3x from both sides. And I'm actually going to just add 2 at the same time. You can make baby steps and do it separately, but, it's up to you. That's going to give me on this side 26 and 2x. And then when I divide by 2 on both sides, I'm going to get x equals 13. Sorry, 23. Nope, hold on. I know where my brain just was short-circuited. This was 22 up here. It was 1. I just didn't see the 11. I just saw 1. My mistake. So that's going to be 22 here. I'm going to add 22, which is going to give me 46. And that's going to give me 23. So again, mistakes happen. We're human. I can make simple errors like that. So this is why we double check our work. All right? Number 3, now we're solving for W. There's 2 ways to do this problem, and I'm going to do them both ways because I see both answers in the classroom, and they're both right. They may not both be on the answer key, but I want to show you both ways. Some people start off by distributing the 2 right away. And they get P equals 2L plus 2W. Now we're trying to get W by itself. So I'm going to subtract the 2L and get P minus 2L equals 2W. And then just divide by 2. And that's going to give me W equals P minus 2L over 2. Or some people say, let's just get rid of the 2 first and get this, P over 2 equals L plus W. And so I'm trying to get this by itself, I just subtract 2, and that gives me P over 2 minus L equals W. These are both correct answers. Why is that? Because on the left side, if I broke this up and put the 2 underneath the P, I'd have this. I have the 2 underneath the 2L. The 2's would cancel, and I would just have that. So they're both correct. All right. Number 4, we're trying to get L by itself. L is over here. First thing I'm going to do is subtract this from both sides. Okay? So I'm going to move this over here by subtraction. So that's going to give me S minus pi r squared. We can move it all at the same time because this is just a quantity. Equals pi r L. Now we're trying to get this by itself. These two things are attached by multiplication. So at the same time, we can just get rid of them by division and put it all under pi r. Cancel, cancel. Now, don't do any canceling over here because that's subtraction sign. Just like on number 3, it's going to be S minus pi r squared over pi r equals L. But just like on number 3, we could break it up and have S over pi r, and I've seen people do this, minus pi r squared over pi r equals L. And what happens is the pi's cancel, one of the r's cancel, and that gives us S over pi r minus just r equals L. And again, this is a correct answer. And so is this. Either one. Just how your brain processes it. All right, number 3. Sorry, 5. Linear inequalities. Now remember, when we're getting in inequalities, this is when you have to be careful about flipping. Anytime you multiply or divide by a negative. Okay? So this is where sometimes it's easier for some people to always keep the coefficient of the x positive, so you don't have to worry about flipping. For example, number 5. If I subtract 3x, I'm going to end up with negative 6x, 7x. Okay? And I'm actually going to do it both ways. I'm not going to do it on all these, but both ways on this one, just to show you why it happens. So if I subtract 3x, I'm going to get negative 7x. If I add 51, it's going to be 91. And then divide by negative 7. And it's going to be x, negative 13, but I have to remember to flip this. If I didn't do that, if I added 4x, the 7x would be over here, and I'd have negative 91, and I would divide by positive 7. Now, there's no flipping. Just because there's a negative in the problem somewhere, the coefficient's not. So notice what happens. I get x greater than negative 13 or negative 13 less than x. These are both the same statement. We always read from the x. So these are both x is greater than statements. Okay, it also says graph on a number line. So real quickly, just, you don't have to put, you can put 0, just put negative 13. And it's an open dot, and it's greater than. Now, the problem here is with this one, people sometimes graph it incorrectly and will graph to the left because they're going the direction of the arrow. That's why we always read from the x. Okay? And then interval notation, which is not on the answer key, by the way, it's going to be a parentheses because it's greater than. And it's going to be negative 13 towards positive infinity. All right? Number 6, we're going to start off by multiplying both sides by 2. All right? And that's going to give me x minus 3 is less than or equal to negative 16. Add 3 to both sides. That's going to give me negative 13. And I'm done. Graph it. Put my negative 13 again. It's less than or equal, so it's an closed dot, and it is going this direction. So when I do my interval notation, I'm going towards negative infinity, so that's on the left side. and the negative 13 goes here. All right, absolute value equations. We always want to get this by itself before we do anything. So don't right now write all of this equals 47 and all of that equals negative 47. Stop that. That is the first most common mistake, is going to get to the two equations too soon. All right? We need to get this by itself first by adding 10 to both sides. Now we branch off into x plus 7 equals 57 and x plus 7 equals negative 57. Don't branch off too soon. Now when I subtract 7, I get x equals 50 and x equals, when I subtract 7 here, we get negative 64. You borrow $57, you borrow $7, that gives you $64 in debt. All right? Number 8, don't branch off. We got to get rid of the 1 and the 2. So first off, we subtract the 1. So that leaves a 2, 3 minus 2x in absolute value bars equals 34. Do not distribute. Most common mistake is to want to say absolute value of 6 minus 4x. No such thing. They're not parentheses. You can't distribute. They're absolute value bars. We divide by 2. And notice we're not branching off yet. Now we have 3 minus 2x in absolute value bars equal to 17. Now, only now, do we branch off. The absolute value is by itself, and now we can do this. 3 minus 2x equals 17. 3 minus 2x equals negative 17. I'm going to subtract 3 from both sides, which gives me negative 2x equals 14. And negative 2x equals negative 20. When I divide by negative 2, we don't have to worry about flipping because it's an equal sign. But if this was an inequality, we would have to flip the sign right now. We get x is equal to negative 7, and x is equal to positive 10. Negative divided by negative. All right, absolute value inequalities. So now we're combining what we've been doing, and we got to remember a few things. We need to get this by itself, and if we multiply or divide by a negative number, we have to flip the symbol. Okay? So first off, I'm going to subtract the 8. So that gives me 2. Absolute value of x minus 7. Do not distribute. Greater than or equal to 36 minus 8 is 28. Now divide by 2. I'm dividing by a positive number, so no big deal. X minus 7 still in absolute value bars is greater than or equal to 14. Now I break it off. X minus 7 greater than or equal to 14. X minus 7. Now, when I make this negative 14, I'm essentially multiplying by negative 1, so flip the symbol. Remember, these are the ones when we're going to have no dab. So when you're done, you should not have two statements going the same direction. Okay? They should either be looking like something like this. Whoops. Or something like this, open or closed dots, whatever. But there is no that. Okay? So that's why we have to flip the symbol when we make the other number, number on the other side negative. Now I'm going to add 7. So x is greater than or equal to 14 plus 7 is 21. And when I add 7 here, x is less than or equal to negative 14 plus 7 is negative 7. So on a number line, I mark my two numbers. Negative 7 is on this side. 21 is here. They're both solid dots. Greater than 21, greater than or equal. Less than or equal negative 7, like so. And interval notation is going to be a union. Be a bracket on the numbers, parentheses on my infinities. This is negative infinity, negative 7. This is positive infinity, 21. All right, number 10, we start off by getting rid of this 3. It's a positive 3, so no flipping. But let's say it was negative 3. If it was, we would change the sign immediately to greater than. Reading left to right. So my absolute value is by itself now, 2x plus 6, less than 36. Now I can break this up. So 2x plus 6 less than 36, 2x plus 6 greater than negative 36. I'm going to subtract 6 from both sides. So that gives me 2x less than 30 and 2x greater than negative 42. Divide by 2. X is less than 15. And x is greater than negative 21. So when I go to graph that, my negative 21's over here. My 15's over here, negative and positive. It's greater than, less than, so it's open dots. Less than 15 is going to the left. Greater than negative 21 is going to the right, so it's in between. And this is really easy to do interval notation because it's just the two numbers in parentheses like that. Okay, compound inequalities. There's two ways to do this. One, you can break it up and write this one and solve it, and this one and solve it. And some people need to do that, and that's okay. I prefer just to put some fence posts up and make sure I remember to do everything, not on both sides, but in all 3 sections. So the first thing I need to do is get rid of the 2. Now, some of you might distribute the 2 and you get 2x minus 6, and that's fine. You'll add 6 and divide by 2. But since these two numbers are both even, I'm just going to divide by 2 right off the bat. But again, if you distributed the 2, that's okay. You're going to divide by 2 eventually. It's just whether you're going to, add 3 to all 3 sections or add 6. But you're going to divide by 2 eventually. I'm just getting rid of it now. So that gives me negative 6 less than x minus 3 less than or equal 7. Now I'm going to add 3. I'm going to add 3 here, add 3 here, and add 3 there. That's going to give me negative 3 less than x less than or equal to 10. So, number line, negative 3 here, 10 here. This one is an open dot. This one is a solid dot. Be careful of that. Now, x is greater than negative 3, so that's going to the right. Less than 10, less than or equal to 10, so that's an in-between. It's an and statement. And this is really easy. Then here, just remember, bracket here, parentheses there. I think I've also forgot. Oh, I did on my number lines. Okay, I can't remember if I put arrows or not. Sorry. All right, this is an or, 2 statements. Remember, this means we're going to have something like this going in opposite directions. So we're really basically just doing 2 different statements. So On the left one, I'm going to add 5. So that's going to give me 2x is less than or equal to negative 13 plus 5. Sorry, minus 5. Minus 5 is going to be negative 18. And when I divide by 2, it's a positive number, no flipping. X is less than or equal to negative 9. Over here, I'm going to subtract 10. Negative 4x, pay attention there, less than negative 34 minus 10 is going to be negative 44. But when I divide by a negative, I've got to remember to flip this symbol, and I'm going to get a positive 11. Number line, negative 9 over here, 11 over here, solid dot, open dot, greater than 11, less than or equal to negative 9. So that's negative 9 going towards negative infinity on the left side. Bracket, parentheses, 11 going towards positive infinity on the right side. And we put the union symbol in between. And we're almost done. This one, we're just going backwards. We're saying what this would look like in interval notation and as a statement. So this is, on your answer key, these are solid dots on number 13, but here it's not. So I'm just going to go with, let's make it match the answer key. So they're solid dots. So that basically just means it's between 6 and 18, like so. If it's between, literally, 6 and 18, well, x is less than or equal to 18, and x is greater than or equal to 6. Remember, we always read from the x. So it's greater than or equal to 6, it's less than or equal to 18, and we graph the overlap. Now this one is a union. So this is going from 10 out to positive infinity, and negative 4 out to negative infinity. And they're both open dots, so parentheses. So that is x is less than negative 4, or x is greater than 10. And that's it.